In this video I want to look at how to take the derivative of exponentials and logarithms that are not base e. In a previous video I proved our rules for the natural log and for the exponential base e to say that the derivative with respect to x of the natural log of some function of x is equal to the derivative over the function. And I also showed that the derivative with respect to x of e to some function of x was equal to the derivative of the exponent times e to that function of x. So in this video I want to look at what we do for logarithms and exponentials with bases other than e. So first let's look at what the derivative with respect to x of some base a raised to the f of x power will be. And to do this we're going to use our base e exponential, but we can rewrite this. Instead of a to the f of x, it will be e raised to the natural log of a to the f of x. Because e to the natural log, the inverse properties cancel and you're left with simply a to the f of x. So these two things are equivalent. And with this in mind, one more property of logarithms and we have an easy problem to solve, because f of x is an exponent, so we can write that as e to the f of x times natural log of a. And this is simply coming from your logarithm property that you can pull an exponent out in front and multiply by the logarithm. So now that we have that, we can just use our rule for an exponential base e. Because the natural log of a is a constant, this is simply a constant times f of x. So the derivative of that is going to be the derivative of the exponent, which is the constant multiple, times f prime of x, times the exponent itself, or the exponential itself. But what do we know this e to the f of x times natural log of a? Well, that's the same thing as a to the f of x. So we can say that's a to the f of x times f prime of x times the natural log of a. So the difference in a logarithm base e and a exponential base e and an exponential with any other base, we're multiplying the exponential times its derivative, or the derivative of the exponent, but when we have a base other than e, we're multiplying by the natural log of that base. And actually we're doing the same thing with base e, but the natural log of e is 1, so it's irrelevant. So in that we've showed that the derivative with respect to x of a to the f of x power is equal to a to the f of x times f prime of x times the natural log of the base a. So now let's look at what we can do with logarithms with a base other than e. So our rule for logs was that the derivative with respect to x of the natural log of f of x was equal to f prime of x over f of x. Well, what if I want the derivative with respect to x of log base some constant a of f of x? Well, to do this we'll just use one of our log properties, and that's the change of base rule, because that's the same thing as the derivative with respect to x of the natural log of f of x over the natural log of a. And this is just one of our basic logarithm properties to rewrite it in that way. Well, now the natural log of a is a constant, so that's 1 over the natural log of a times the derivative with respect to x of the natural log of f of x. Well, we know how to take that derivative, so we'll simply get 1 over the natural log of a times f prime of x over f of x. So we can show in that for a logarithm with any base a, its derivative is going to be the derivative of the argument f prime of x over f of x, the argument, times the natural log of the base of the logarithm. So we see with the exponential that the difference in an exponential base e and base some other number was that we multiplied by the natural log of a, its base. And same with the logarithm. it's the same as the natural log, only when the base is something other than e, we'll divide by the natural log of a.